Welcome back, students. In the second part of this video, we were discussing about the spherical mirrors and certain terms, basic terms related to the spherical mirrors. First, we have to consider what is a spherical mirror. In the last section, we have considered the plane mirror or a planar reflecting surface and the image formation by that planar reflecting surface, the characteristics of the plane mirror. Then in this part we were considering the reflecting surface is not in a planar way, it is just a curved manner. Then in two ways we can consider the curvature. One is the reflecting surface can be considered curved outward, and another possibility, the reflecting surface can be considered curved inward. Since these curved mirrors are part of a complete sphere, it is collectively known as spherical mirrors. In simple way we can consider, just you imagine that in your hand an ice cream ball is there. When we open the lid of that ice cream bowl, we obtain a small portion of that, a complete sphere. Then just imagine that lid has a smooth polished surface, then it behaving as a reflecting surface or a curved mirror. If the reflecting surface is the outer side, that is it is curved outward, then that is known as a convex mirror. And if the reflecting surface is curved inward, then that is known as a concave mirror. The reflecting surface is curved outward or bulged outward, then that is a convex mirror. And if the reflecting surface is curved inward or bulged inward, then that is a concave mirror. Okay, next we have to consider certain terms related to these spherical mirrors. Mainly we have to consider few important terms related to the spherical mirror. The first one is pole. The pole of a spherical mirror is usually represented with the capital letter P. Commonly we are using the notation capital letter P. What is meant by pole of a spherical mirror? The pole means it is the midpoint or the center point of that reflecting surface. Whether it is a concave mirror or convex mirror, the midpoint or the center point of that reflecting surface is known as its pole. Next term is the center of curvature. It is the notation used for it is capital C, center of curvature. The center of curvature of a spherical mirror means it is the center of the sphere from which that spherical mirror is formed. We already mentioned that the concave and convex mirrors are formed from or obtaining from a complete spherical shell. So that each and every sphere has a particular center, and the center of that sphere from which we obtained this particular spherical mirror, that center is known as its center of curvature. The center of the sphere from which the spherical mirror is formed, that is known as the center of curvature, and notation is capital letter C. Next term is radius of curvature. It is representation or notation using is letter R. Normally capital letter R is using, sometimes small letter r is also using. And radius of curvature means the radius of the sphere from which the spherical mirror is formed. Concave or convex mirror is formed from a sphere, and that sphere has a particular center. That center is known as its center of curvature, and the radius of that corresponding sphere is known as its radius of curvature. Or in another way, in a simple way, we can represent as it is the distance between pole and the center of curvature. But the standard definition is it is the radius of the sphere from which that spherical mirror is formed. Principal axis means it is a straight line passing through the center of curvature and pole of a spherical mirror. Whether it is a concave mirror or convex mirror, a straight line which is passing through the pole and center of curvature. That line is known as the principal axis. Next term is very important one, that is the principal focus, and the notation used for that principal focus is capital letter F. Keep it in mind, capital letter F is used for notating principal focus. How can we define the principal focus? It is the point on the principal axis at which the parallel light rays converges or seems to be diverging after reflection. It is a common definition given for concave and convex mirror. In a concave mirror, light rays are converges to a single point, and in convex we can see that the light rays seems to be diverging from a common point. That particular point is known as the principal focus, and that should be always lies in the principal axis, and also it should be at the center of the radius of curvature. And his it is principal focus is a point on the principal axis at which parallel light rays converges or seems to be diverge after reflection. And the last term is focal length. The notation using is small letter f. For focal length we are using small letter f. Capital letter F is used for principal focus. Now it is the focal length. Focal length means it's very simple. It is the distance between principal focus and pole of a spherical mirror. Whether it is a concave mirror or convex mirror, it is possible to measure the distance between the pole and the principal focus. That distance is known as the focal length of the spherical mirror, and small letter f is used to notate that one. We already mentioned that the principal focus is always existing at the center or at the middle of the radius of curvature. So there exists a relationship between the radius of curvature and focal length. Radius of curvature means it is the distance from pole to center of curvature, and focal length means it is the distance from pole to focus, and the focus is always at the middle of the radius of curvature. So focal length is always half of the radius of curvature, or we can write small letter f focal length equal to radius of curvature divided by 2, or f equal to r by 2. So these are the basic terms related to spherical mirror. First one is the pole, that is the midpoint or the center point of the spherical mirror. Capital P is the notation. Next, radius of curvature. It is the radius of the sphere from which the spherical mirror is formed. Capital R is the common notation. Then center of curvature. It is the center of the sphere from which that spherical mirror is formed. Capital C is the notation. Then we mentioned principal axis. It is a straight line passing through the center of curvature and pole of the spherical mirror. Then the important term, principal focus. It is the point on the principal axis at which parallel light rays converges or seems to be diverge after reflection. Capital F is the notation. And last we mentioned focal length, that is the distance between principal focus and the pole. Notation using is small letter f.